Hello, and welcome to the Boffin Buzz, the podcast for anyone fascinated by farming's future. So hello again, and welcome to the Boffin Buzz, and part 2 of our exploration into the world of AI and autonomy and robotics and so on in farming. And I'm delighted to welcome back Charles Vase from Photonex.
Hi Tom, thanks for having us on.
And Callum Chalmers from FarmScan Ag.
Yeah, hi Tom, good to be here, thank you.
Great. Now, just to remind everyone who's listening, there are CPD points available for this Boffin Buzz podcast. So you will have heard the first part of the CPD code in part 1. If you're coming straight into part 2, don't forget to listen to part 1 as well, so you can get your first part of the code. And then at some point within this podcast, we will be telling you the second part of the CPD code. All you have to do is to email us at info@boffin.org.uk with the full CPD code to get your points. So anyway, now in the first part of this podcast, we had a really fascinating talk about AI and some of the basics and some of the background to AI and autonomy. And bringing in some of Charles's and Callum's experience in what they've been doing, some of the challenges that there are, and also some of the opportunities that this technology can offer. We're going to be looking in more detail now at Slimers. So as many of you will know, Slimers is strategies leading to improved management and enhanced resilience against slugs. It's a £2.6 million program, a project DEFRA funded over 3 years with 6 industry partners. Boffin leads the project, and we're delighted that Photonex and FarmScan Ag have come on board. As many of you may know, this follows a small robot company that was a project partner, unfortunately went out of business earlier on this year. And so we were delighted to that Photonex and FarmScan Ag came forward. We've been talking in some detail, actually, for the past 2 or 3 months now about the technologies that you're bringing, the opportunities, and so on. So, and that's really what we want to delve into in a bit more detail today. So it's fantastic to have you on board. Can I just ask you, first of all, each of you, what are the sort of specific aspects that excite you about this project, and perhaps are a bit daunting or a bit challenging or whatever? If we can turn to you first, Charles, what do you feel? What are you looking forward to getting involved in this project, and are there any aspects that you think, oh gosh, I'm not quite sure how this is going to turn out?
Yeah, well, it's an ambitious project for sure. I think that's always a good sign, and sort of vindicates the DEFRA sort of badge of funding that it's received. I think for me the exciting thing is about deploying quite new and cutting edge detection onto traditional farm equipment. We knew Small Robot quite well, friends and customers, and deploying on those kind of robotic systems as a sensor provider is quite easy. There's a lot of infrastructure built up about plugging in, plug and play. There's ROS, there's agreed standards. The world of farm machinery went a slightly different siloed approach, and so we're very keen to be able to translate what we've seen on smaller, more sort of R&D or sort of newer systems onto more traditional pieces of equipment. And the bit that scares me is the speed. We spend a lot of time in glasshouse and horticulture, where everything happens a bit slower, and not necessarily the growth of the plant, but the movement of the systems, how we operate, how much coverage we get. But starting to cover, instead of big hectares of glass going into tens or hundreds of hectares quickly means we have to really think of a slightly different way of how we get that data in a cost-effective way to be processed. Because if you spend any time on the phone in a lot of these areas, you don't get good signal, and we rely on keeping our devices cheap by uploading a huge amount of the data, and that's not always going to be possible. And so we have to come up with a good way to be able to compress and move that data around, which is going to be fun, I think.
Yeah, well, I guess that's what we're going to be finding out over this project. If I can turn to you, Callum, and same question really. I mean, what are the aspects that excite you about this project, and what are the aspects that you think, gosh, this is going to be quite a tough nut to crack?
Yeah, I mean, our background is in that implement technology. So, we're really excited about trying to become more precise, especially with, what has previously been quite broad approaches with pelleting and that kind of thing. And being able to actually have a targeted aspect to deal with slugs, that part of us, of our company, is really interesting. That's our bread and butter technology. And we're really interested in, can we actually have something that's more accurate than going over and broad applying over an entire field. One of the challenges, like Charles said, we've got varying speeds, and we're supposed to do this all autonomously as well. So it's sort of the marrying of the two systems into a harmonious output that makes sense and is commercially available for a farmer. Now, that's a short sentence, but is a lot harder to make that a reality in the real world. And at the same time as, there's all these challenges, we have to make sure that they're farmer ready. So, having people like Boffin and the farmers associated with it's going to be really important. And that's going to be one of probably the biggest mitigators, to be able to make sure that this is ready to go onto a farm and be used in the real world.
Yeah, no, well, as you mentioned there, I mean, so if I just give a little bit of a background about the project. So we are looking to develop two services as part of this project. The first one is patch location of slugs. So this is work that Keith Walters has been leading at Harper Adams University. And his previous work has already identified that slugs gather together in patches. And not only that, you can actually use the soil data to predict where those slugs will develop, which is, very important in itself, in terms of, rather than treat the whole field, as you were saying, Callum, we can just treat specific patches and very reliably control the slugs within it. What that also tells us is where within that field those slugs are going to be. So the other aspect of what we're developing as part of this project is autonomous slug control. So, rather than use pellets, we could actually go to these patches where the slugs are going to be, identify the slugs, and then spray them with nematodes. So many of you will know about Nemaslug, which is a nematode that eats slugs, but it would be prohibitively expensive to put it across the whole field. If we can just find the slug and then spray it, then that gives basically it costs, I think, about a penny a time to do that. So, and that is the idea, that at the end of this project, we will have the two services. One is a patch prediction service, and the other is a way in which we can autonomously locate and treat slugs. Now, one thing to point out is that the proof of concept has already been done through the SlugBot project, which was, again, another project that was funded by Innovate. And it's that proof of concept developed by CHAP, now the UK Agritech Centre, that we're looking to take on within this project and turn into a service with the help of you guys, really. So, and we've already had, a few meetings talking about, how we're going to be taking this forward. I mean, in terms of as you also identified, we're looking to work with farmers as well. This is very much a farmer-led project. We've got our 30 Slug Sleuths who are doing a lot of the monitoring work at the moment on the patch location side of things and developing that side of the service. But we also want to involve them as well in right from the outset in some of the research work that you'll be doing. So, Callum, would you like to sort of talk us through one of the things that we're hoping that our farmers will be helping us with over the next few months in terms of how we're going to be developing that?
Yeah, definitely. I mean, Charles, our systems have to work pretty harmoniously. So we've had a couple of conversations, and it's very early days in the project, so we're still sort of scoping that part out. But it's going to be important that we can talk, which means that we need to be able to effectively get some information about where the slugs are, and that's largely Charles's remit. So one of the key parts is going to be engaging farmers to be able to reliably test our finding of that, which will also be associated with in terms of the physical aspect. So Charles is very much on the find the slugs, and we're very much on what do we do once we found them. So we'll be looking to have their support and their opinions on what's going to be the most effective way, and what would they ideally, in an ideal world, how would you envisage using this system? Because we want it to be easy to use but also effective. So it's no good having something that's so difficult to use that no one actually wants to use it. So that's going to be one of the key things, is engaging with them, but then also using them as a test platform. So once we get some prototypes up, we try and operate on a pretty rapid prototyping stage, because it's always better to get some in-field conditions, in-field testing. It tells you a lot about, that's what we learned at Hands Free, about what is going to work, what isn't going to work, and it also gives the opportunity, things are actually happening, things are being produced. So if we can get some feedback quickly, we can also use that to pivot into a new area, or make some rapid changes that we need to make it more industry ready.
Yeah, no, I guess from your point of view, Charles, the sort of number one aspect is in order to have something that autonomously, something that will detect slugs, we need to photograph a lot of slugs, I guess. So that's one of the first challenges of the project. Am I right? Do you want to sort of talk around that?
Yeah, I think building a training set to know what slugs look like under any kind of imaging is normally sort of the first port of call. So using the facilities that sort of ATC have, also in combination with other slugs that a lot of the farmers on the project will inevitably sort of acquire over the course of the project is pretty crucial. And it's not just about the slugs; it's about what kind of environment, what kind of soil, what kind of tillage, and that basically gives us an indication of whether we can see them, whether we're seeing the symptoms, whether we're seeing the trails, what kind of time of day or night are we seeing them, all that kind of information. It really informs the technical bit about how it's going to be possible to detect these during farm operation on the site. I think that's the real crucial element at the beginning. And I think the bit that happens kind of parallel to that is trying to work out, well, how is this actually going to work commercially? Because building something that can do something is a lot easier than building something that people will pay to do something and will actually maintain a viable business. And that's always where there's a challenge, right through to timing. Seeing a slug and make a decision there and then is all well and good, but are you going to have to preload your pallets by then? In which case you're going to apply them anyway. Do you need that? Do you need to know before you start loading up a system what's there? Or same with the nematode. So it's all that, trying to really work through we call it like a trial spec or a system pipeline. How is it going to be detected? When's that information we given back, and how is that going to save money for the farmer? Because if it's not, then we're not going to be able to charge for it, which means it's not a viable business and therefore not a viable project. So we have experience in this, particularly on sort of the part, and we kind of try and push it towards the path of least resistance and then expand out. So that's going to be our main focus. And yeah, it's a 3-year project, but we only have two years left. And in the world of farming, we can double up on wheat seasons, but even that's not a huge amount of time. So we're going to be pretty hit the ground running, I think, is the expression we're going to need.
Yeah. Okay. Well, let's talk about the first steps, and let's talk about what we're the challenge of detecting slugs. So the thing about weeds is that they're always there in the field. I think most of the systems that are developing for weed detection, the challenge there is to know where they are in the field, and typically we're talking about a vehicle that's passing through, be it a boom sprayer or whatever, with sensors on it that can detect the weeds, but it's detecting something that's in motion, if you like. Whereas, but they're always there in the field. What we're talking about with slugs is something that, because we know of this, the patch location that they gather in patches, it's likely that it's going to be a vehicle moving from one patch to another within the field. And then it can pretty intensively scan those areas. And so we're not talking about it, the challenge there isn't the motion element. It's more to do with whether the slug is actually there. And that's the thing. It's an animal that spends a lot of its time underground. And the other aspect of that is that they're basically nocturnal animals. They're out around at night. So I guess, coming back to you, Charles, what sort of equipment are we talking about here that's going to actually detect it? Do we need a special camera at night? Do we need lighting and things like that? What are we talking about here?
Yeah, it's a good. I mean, what we typically want to talk about is something that's quite challenging is how we're going to make it easier. So things like operating at the same time of the day or night that the slugs are operating. You know, if they're going to be around at night and visible, then that's the kind of time. Then that leads itself to, well, how will that be used? If there's more automation on the tractor, obviously coming from the rest of the consortium, therefore that becomes less of a challenge trying to get usage of that kind of equipment at those times. Lighting's always a challenge. It's the one that imaging often gets wrong when it's sort of first deployed. You need to be able to control the lighting, whatever kind of cameras you're using, even more so with the kind of cameras that we'll be deploying. So yeah, I think whether you're just detecting patches or the whole area, I think one thing we need to be clear about is that whilst this system will be able to detect slugs, the focus for it to be a commercial viable platform is it'll also have to be capable of doing other things, whether it be weeds, whether it be other kind of nutrient impacts, because those are kind of capabilities that we've already built. So being able to put that in the same platform means you get let's say a front linkage loaded sort of boom that can do a number of operations, and that becomes a viable then commercial offer for farmers rather than something that's quite niche and good as a project. So we have to kind of keep the project, but also in the scope of the commercial direction of the company and the industry together, and also not waiting for farmers to all adopt these autonomous driving around tractors at night, because I think that's another challenge is speaking to the farmers and actually ask how many of them are going to have that kind of system off the bat. So there's going to have to be how's it going to work on the interim, how are we going to retrofit it. So for me, having done a lot of the IPM targeting for glasshouse work, and we work with agronomists in that sector to help build maps where they can put beneficial insects and biologicals in certain locations. The technical bit is the easy part for one. The hard part here is going to be how can we do it technically that's also going to lead to a sensible roadmap for it to be exploited. And I think the real change and shift of the DEFRA funding that sort of took over, sort of still deployed by Innovate but now funded by DEFRA, is that farmers want stuff now. They don't want to be seeing posters of stuff what it's going to be like in 2050. So it's trying to, within the realm of the project, get it into the commercial feasibility stages. And I think that's where most of the work will be done on our side.
Yeah, no, I wanted to sort of focus on, you know, the sort of imminent work that we're hoping to do with farmers and how farmers can help within the project. As we were saying, then, you know, the first step is going to be gathering loads and loads of images of slugs so that we can train the AI to reliably detect a slug. And as I say, the proof of concept of that is there. We know that it's possible to detect a slug, but obviously we need loads and loads of images, as you say, to train the AI model. And one of the aspects of that is but as you intimated, Charles, it's about getting the consistent approach to taking these photographs. You know, something that's realistic in the field, that's going to happen, but at the same time is going to be reasonable for the AI to then work through and work out where the slugs are in the images. And if I can come back to you, Callum, one of the aspects that I think you've been looking at is a sort of rig that we can use so that our farmers can go out into the field and take some images of slugs at the right time of day, first of all, which is probably going to be sort of nighttime, dusk or dawn or whatever. And then, could you just sort of talk us through your thinking about, you know, what sort of rig that we're going to use to put a camera on in order to do that?
Yeah, so there's a couple of avenues that we've gone down. The main thing is we want to make it easy to use and simple to transport. So you don't need to be carting around heaps of equipment to be able to do this. We know that because we need so many images, this needs to be an easy to use system. So we're working closely with the consortium. We're trying to go down the route of handheld. So having something that we can take into the field and then leave overnight. So rather than someone having to sit there for the whole evening, and this is all just based around being able to get lots and lots of images in the easiest way possible that puts no onus on someone having to physically do the work all throughout the night, which would be not exactly enjoyable for anyone, I can imagine. So these handheld rigs we're designing so that they can sit in the field, get set up, and then collect data over a long period. Slugs don't move very quickly or very far, as we found, so not having to move the rigs initially, that's going to be really important. Moving on from there, like Charles said, there's a commercial aspect to this. So we are looking at moving and that's a different environment. So we're building something akin to a spray boom that can be carried behind, whether it be an ATV, a 3-point linkage. We're still very early days, still looking at what the best option is. But having something that can be towed along to generate the same kind of images, but from a moving platform, so that when the time does come for that commercialization and that actual application stage, we have the benefit of the choice of whether we can go stationary or moving or potentially very slowly, or how fast can we go? Realistically, the real world, people want to go quick. Why do something at 6K when you can do it at 20K? Well, if it costs you 20 times as much, maybe 6K is great. But this is all things that we're going to work out over time.
Yeah, no, if I can, I mean, one of the challenges as well within this is that eventually we also want to be able to apply nematodes to the slugs. Once we found them, is apply it, and so we're talking about some sort of spraying device. Now, in part one of this, you talked about the hands-free hectare project, and we talked about some of the difficulties of applying autonomous technology into the field. One aspect that we didn't sort of discuss in any great detail is this area of actually spraying autonomously. And so could you just sort of talk me through some of the challenges around, not only getting to the right place in the field, but then precision applying with a sprayer or autonomously? What are the challenges we're talking about there?
Yeah, so I think you've now basically the two biggest ones, which is one, being in the right place. So if you're not where you need to be, you've got no chance whatsoever. So hopefully we're going to have the work from Keith and those guys to narrow down the field that we need to look at, and then from that have a very small area that we can investigate, and then we're going to be relying on Charles to sort of back us up there and give us some good feedback on whether or not there are slugs in that region. Once we've detected the slugs, the next challenge is actually, like you said, accurately spraying them. And what resolution can we get to? And that's the key thing in this, is the resolution. Is what is the minimum sized spray? We know how big a slug's going to be. In an ideal world, our application would be the same size of a slug, so we can treat them independently across a boom. Now, with the conventional technology that's available, we're not sure that that's going to be possible. So we're going to have to pick somewhere that's a healthy medium from a cost perspective, without having this becoming an extremely expensive system. The other thing we really need to focus on is a lot of these mixtures, they're pre-mixed. And if we pre-mix the nematodes, you're sort of committing to using that much. So at that stage, it doesn't really matter. Or we have a certain amount of slugs we can treat, and if there's more than that, you have to go back and start again. So what we're looking at is, can we inject this? Can we do some way of having an on-demand system rather than a fixed amount, so that when you go out, if there's no slugs, well, it's cost you nothing, or it's cost you some diesel or whatever it is. We really need to make sure that that's part of that commercial viability, that if you're going to invest in these nematodes, it needs to make sense that you're not just going to go out and put them everywhere, but you're also only going to treat what you need to. So I think there's a real balance there that we need to find, but that's what the whole goal of the project is, and that's what over 2 years we're going to find out.
Great. Now, I'd like to talk timescales as well, and as you pointed out, Charles, it's actually quite a challenging timescale that we've got. It's a 3-year project, but we're already more than a year now into the project. So let's just talk about, what realistically, where we hope to be in, say, 6 months' time, and then 12 months' time, and then 18 months' time. Could you sort of give us an idea, Charles, of what you're hoping, just an outline timescale, the ambition would be over the course of the next sort of 12 to 18 months?
Yeah, I mean, for sure. I mean, I think one of the reasons why it's sort of been feasible to bring Callum and myself in at this stage is that we are already operating in this kind of area, so we're not kind of starting from scratch. We're sort of joining the project already a year in, but we have, I mean, Phoenix has just completed what was the Spraybot project, which was about selective application of fungicide in field. And so there already is a 10-meter boom system that does imaging at a certain set of speeds that we sort of can start with and work with that. So I think the first 6 months are normally kind of working out where we are. And what I mean by we as a consortium, where are we in terms of tech partners? What do we have? What do we need to do? and also we as in the farmers being like, well, this is how it will work. Even the meetings we've had already with yourselves and the Boffin network, learning about when are they going in the field, what are they driving around, just those kind of things for data acquisition is really, really helpful. So the first 6 months is always a bit of a look-see, and I know it's happening mid-project, but that can be really important for steering the rest of the project. If you head off in the wrong direction, it takes a lot more time and money to get back. But within 18 months, I think it's very feasible for us to have a module. The length and size of that module, I think, is still up for discussion about what is a sort of demonstrator. But for me, it's a pre-commercial demonstrator of a system that plugs into a traditional tractor, run with photonics cameras and farm scan ag sort of control systems that can be taken out. I mean, that is the aim of the project, and I know that my shareholders won't be happy if we don't get to that point from our point of view. And I think that's where DEFRA is sort of expecting us to get to. It's challenging, but it's definitely going to be feasible. There's the right size and the right budget in the project to do it. I think we need to make sure that ideally we don't have as bad a season as we've had in the past sort of 2 years. We kind of want to be looking for slugs amongst a kind of a standard operation, not being concerned about if we're going to be causing issues with the soil or other kind of disturbances with the wet weather. So it's going to be, it always is a challenge, but an exciting one. I think we've got the right partners involved. I think it'll be quite exciting to reconvene sort of maybe in a year's or 18 months time to work out how far we got that. But I've got good ambitions of this project, and I'm pretty sure we have the right consortium in to do that, and have delivered a few of these projects.
And as I've said, farmer involvement is absolutely key in this project. And we've got 30 Slug Sleuths who will be doing some of the field work around some of the things that we've been talking about. But also, anyone can get involved. And the Slug Circle is free to join. If you go to slimers.co.uk, you can join the Slug Circle. That's free to join. And the whole point of the Slug Circle is to bring your experiences, bring the discussion around slug control. And Charles and Callum, I sincerely hope you'll be joining the conversation on the Slug Circle over the coming months. But the important thing, as you've talked about, Charles, is what we really want to learn about is, how is this going to be practical? We want to know more about how farmers would like to control slugs in the field, would like to spot slugs, detect them, control them, and so on. All the various things that we've talked about, all the challenges, all the barriers. If we can get more farmer input within this, the more farmer input we can get, the more we can help refine the service that comes out at the end of this. So now, one aspect that I want to, because of course, one of the things that we're hoping to get, certainly over the next few months, is a whole raft of images of slugs. Someone's got to go through those slugs and identify them, I guess. And I just wanted to sort of look at that aspect in particular, if that's all right, Charles. In terms of what are we talking about there? I mean, we're going to have all these images of slugs. What does the tech do? Can the tech actually decide where those slugs are, or does a human have to go through to a certain extent in order to train that data set?
It's a really good question. I mean, traditionally we work with pre-symptomatic conditions, so outside that, things like disease or nutrient stress. So there is no way of labeling that. You have to deliberately create situations where you know what stress that plant is under, and that becomes your label. In this sense, slugs are visible, which is a benefit. So it allows us to use this application. What you tend to do is take a large number of picture slugs, typically into the millions, if it's an automated kind of process, and then a small subset of that you can get labeled by a person. And what that means is when you create automated, because we're talking about AI, about detection of slugs, but even just identifying an area that could be a slug that then goes into that AI is another kind of software sort of function in itself. So you can to develop those and know how well you're operating. You compare those to a manually labeled image. You try different algorithms, different approaches, see which one gives you the best performance because you've got some labeled areas. So yeah, getting some willing individuals to draw around pictures of slugs, a few pictures of slugs. I don't think we need to be too crazy here. We're not dealing with color images, so it'll be quite quick for us to find out what the spectra of a slug is. and we've touched on it a few times about in the previous episode what spectral imaging is, but it characterizes tissue, and slugs and leaves have very different tissue, so they will respond very differently. So that bit should be quite quick. I think the hard bit is going to be identifying slug or seeing the slug at all underneath all the stubble. I think that's where a lot of the work will be done, is orientation of cameras and speed of device and that kind of thing. Whereas slug in front of camera, I think shouldn't be too bad.
Yeah, well, hopefully, I had quite an interesting experience recently, Charles. So at Open Farm Sunday, we did a spot the slug competition, and we had some images of slugs, and I showed them to people to see if how good they were at identifying slugs. And I have to say, actually, the people I asked were pretty good at spotting slugs. And we're talking here about children's school children's age, and they were actually So I was flicking through these images quite fast and asking them to spot the slugs, and they were pretty good at it. So I'm wondering, we've now got quite a following of slug scouts. So sort of following some activity that we've done on Boffin, we've gathered about 18 to 1900. Slug scouts, people who are really, really keen to be involved in the project, all keen citizen scientists. I'm just wondering whether we might be able to use this new gathering to help us spot some of these slugs. Perhaps make a game or something like that might be able to train the AI. I don't know whether that thought fills you with dread or whether that's.
No, absolutely. I mean, the human brain is amazing for sort of seeing patterns and patches and trying to identify those kind of things. You can't log into a website now without identifying motorbikes or traffic lights or those kind of things. So there's definitely a way for us to deploy a website for sure that people will be able to go on and click on and label pictures of slugs. Maybe we can do it like that, and we'll see how many of the samples that are captured we actually manage to get labeled. I think there's no problem in doing that.
Yeah, no, well, it's something to explore anyway. And then looking at the autonomy side of things, Callum, I mean, where specifically are you keen to get the farmer involvement and sort of the feedback from our slug scouts, from our slug sleuths, and so on? What would be specifically useful as far as you're concerned?
Yeah, I think sort of Charles did touch on it. It's that use case. It's working out exactly the easiest and the most effective way that we can integrate with what they've already got.
Sure.
And that's from a full robotics perspective, but also even a semi-autonomous. It's how can we make the treatment of slugs, a simpler, better, more effective process, ideally, and integrating directly with robotics. And then leading on from that, I don't think it's going to happen this year, but definitely looking at trials next year and working with people to understand if this is what the solution looks like. Does that align with what your future, what you think the future is? Because realistically, you can't make a system these days without farmer buy-in. They don't want it. It needs to be fit for market, and to do that, you need to get it in front of them and have them see it and believe in it. So that's going to be a key part as well.
Fantastic. Well, as I say, anyone who wants to get involved, if you go to slimers.co.uk and just follow the link there to join the Slug Circle and be part of the discussion, you can help shape the project. You can really bring some of that involvement through to it. Now, before we go, just to remind everyone listening that, of course, this podcast there are CPD points available for this podcast. So we told you about the first part of the code in our episode 1. So the second part of the code is, wait for it, 2425/K. K for kilo. So 2425/K. If you send your email to info@boffin.org.uk and quote the code with the first part, and then the second part is 2425/K to receive your CPD points. Great. Well, now before we go, I just wanted to ask, what what is your just very briefly your idea of success? We get to the end of the project in, I think it's May 2026. I think we're talking about here. Callum, what would be your thoughts on what would success look like to you in May 2026?
Yeah, look, I'd love to have I think success at the outcome, the end of the project is going to look like a modular system where we've got whether it's over 1 meter or 10 meters, we have a system that's really effective, but it's also scalable and usable in different environments. So that means that we have manufacturers that can utilize it, we have farmers that can utilize it, and we also have other robotics companies that can utilize it, rather than having a system that's so locked down that it's just one thing that you have to buy. That technology is so applicable that we can use it in a lot of different other areas. And whether they've got a small machine or a big machine, the technology is the same. We're detecting slugs, we're treating slugs. So my success is we can treat the slugs, but we can do it in a modular way that has greater market applicability. Yeah.
Fantastic. And same question to you, Charles. What does success look like in May 2026?
I think I would agree with Callum. I think to be able to go on to one of our websites and buy a sort of a combined retrofitted item that can do spot spraying, and I think slugs are going to be the exemplar, but I think we'd be very keen to expand that out. I mean, the idea is a location stamping and a spray control of a system in a location. It's relying that onto other use cases can be very quick, especially if you've just given us an idea for an app of labeling things in field. I think we could definitely get the farming community behind your podcast, logging on and labeling images. I think that's we could speed things up tenfold for sure.
Yeah, well, absolutely. Well, as I say, look out for more on that. Please do join the Slug Circle, where we'll keep you up to date with all of the progress through the project. You will very much be part of contributing to that, whether it's spotting slugs, whether it's literally helping in the field with some of the monitoring and trial work that we'll be doing, whether that's your input, your experience. We want to hear from you. We want you to bring your experience and your thoughts to the Slug Circle. As I say, Charles and Callum, and our other experts as well. Generos, no one knows more about slugs than Generos, who's our technical lead on the project from UK Agritech Centre, and also Keith Walters from Harper Adams University. He's also going to be contributing on the Slug Circle. We've also got the team at John Innes Centre who are doing some work looking at slug-resistant wheat. I won't go into too much detail on that today. That's for another day. But no, listen, thank you so much, Charles, and to Callum for joining us. And thank you, everyone, for joining us on this week's episode of the Boffin Buzz. And we look forward to seeing you next time. Thank you very much, and goodbye.